Hi everyone, this is Fredrick Mlenga. So today we wanna start looking at the Thermionic emission. But before we start looking at that, let us understand few things. These few things, when we understand them, definitely we are going to enjoy this lesson. So from chemistry, we did learn about the structure of an atom. And we learned that the structure of an atom contains protons, electrons, and neutrons. So mainly we just look, we are concentrating much on electrons. So we know that protons are positively charged and they are found in the what? In the nucleus. They are found in the nucleus, while electrons are negatively charged and are found where? Are found in shells. That's what we learned, if I remember. That's what we learned in chemistry. But let's add a few things from what we learned. So since protons are positively charged and electrons are negatively charged, definitely there is the force of attraction between these particles that actually hold these particles inside an atom. But what if we add energy to this atom? So we know that in the first shell, the highest electron that can be occupied there must be 2, but the rest of shells can occupy at least maximum of 8 electrons. Now, these shells are also called energy levels. They are also called energy levels. Why? They are called energy levels because the electrons that are found in each shell, they possess to have energy. So the first shell will only occupy with electron that has got some energy, electron. So again, the second energy level, electrons that have got same energy will occupy there. So let's imagine maybe these first 2 electrons, they have 3 electron voltage, and these who are here on the second shell, they have maybe 4 electron voltage, and the one in the last one has got maybe 6 electron voltage. Now we decide to give this atom energy. We apply energy to this atom. Okay, so what will happen is that this atom will absorb this energy. Even electron, they will also absorb this energy that we are supplying to this atom. So meaning their energy level increases, so they obtain more energy, and when they obtain more energy, it means this shell now, for these electrons that are in the first shell, this shell can no longer occupy them. They will jump to the next shell. Okay, because they have graduated, they have gotten another energy. When we continue applying more energy, okay, they will again absorb this energy. Okay, they will again absorb this energy and jump to the next shell or next energy levels. Now at one point, these electrons, they will move away from the nucleus, or they will be very far away from the nucleus, such that the force that exists between electrons and proton can no longer pull them back, and they will be lost, they will go. Once that happens, it is said that an atom has emitted electrons. By what means? What has made this atom to emit electrons? Remember, we applied energy to it. So, energy in science is called thermal. So, thermal in science means heat energy. And ion so thermal means heat, and ion means charged particle. This can be either positive or negative charged, but we understand that electrons, they are negatively charged. Oh wow. So let's combine these two. So these two going to give us what we call thermionic emission. Thermionic emission. Thermal, heat, ion charged. So the process by which an atom emits electrons or stream of electron due to energy supplied to it, it is called thermionic emission. So let's put now a very good definition to this. So we'll define this as thermionic emission is a release of electrons from the heated metal or metal surface. And these electrons that are emitted are called cathode rays. So cathode rays is a stream of electrons. Electrons emitted from where? Emitted from the surface of the hot metal. So the ground idea is that when we heat a metal, it emits stream of electron, which we are calling cathode ray. Now let's discuss the production of cathode rays. Some scientists like J.J. Thomson and Crookes, they developed what we call a discharge tube or cathode ray tube. So let me put it back on the diagram. All right. So our main instance here is to explain how we can produce cathode rays. So we should have first high voltage source. We should have higher voltage source, like we can see there, high voltage source. Okay, then we connect the positive terminal to the anode, then the negative terminal to the cathode electrodes. These, they conduct electricity. Then initially, when the tube is still filled with air and the circuit is complete, there was no current detected. Okay, but it was discovered that when some air was withdrawn from the discharge tube, leaving the vacuum inside, the pressure reduced. So pressure reduced at least maybe to 0.001 mm of mercury. Okay, current was seen flowing through the tube. So when the pressure was reduced, the electron that was emitted from the cathode was going towards the anode. Okay, so they ionize the air particles inside and move to the positive charge. Oh well. So as they continue pumping out the air, reducing the pressure, they notice that the space between the cathode and anode electrode was becoming darker. So they gave this space, which was coming darker, as Faraday's space. Okay, as they continue again reducing the pressure, this darker side went beyond what? Beyond the anode, and they started glowing greenish on the sides of the tube. So then you might ask, why did they give these electrons as cathode rays? They gave this name because they were coming. Okay, so we want to answer the question, why did they decide to give this stream of electrons as cathode rays? Oh well, it is because they were moving from cathode electrode going to the anode. Hence, they are named as cathode rays. Okay, so what is the main point are we getting from the production of cathode rays? Is that cathode rays are produced in the discharge tube, okay, which contains anode and cathode electrodes, and the condition required is that you should have higher voltage source and the pressure should be reduced, because when they tried to produce this and when there was air particles inside the tube, they could not see the current, but when they reduced the pressure, the cathode rays was produced. So meaning the presence of too much air inside the tube increased the pressure, which is not required for production of this cathode rays. So now let's discuss the properties of cathode rays. Oh well, the first thing is that when they tried to get an opaque object and pressed inside or pressed between the stream of electrons, maybe like this, they pressed it there, they noticed that the dark shadow was formed on the other side, okay, suggesting that they were blocked. So they travel in the what? In the straight line. So the first point or the first property is that cathode rays travel in the straight line and they are perpendicular to the surface of the cathode. In what sense? So if this is our cathode, here, they form a 90 degrees. Okay, so they are always having a 90 degrees formed or perpendicular to the surface of what? Of the cathode, moving in the straight line. What's the next property? They noticed that when they brought the magnetic fields, so, and maybe the north pole that side and the south pole on the other side, they noticed that these cathode rays were diffracting towards the north pole of a magnet in the magnetic field. That's the second property. So the point is that cathode rays, they diffract in the magnetic field, and the pole where they go is to the North Pole. When they brought the electric field nearer this stream of electrons, they brought electric field near they noticed that also these cathode rays, they were diffracting towards the positive plate of electric field, suggesting that when you press them in the electric field, they'll be diffracted towards the positive plate. Why? Because they are negatively charged. So electrons are negatively charged, and this also made them to conclude that since they are being attracted to the positive sides of the electric current, they are negative charged. Okay, then what other properties does this cathode rays exhibit? At one point they got a wheel and pressed it inside the stream of electron, and they noticed that this wheel was pushed forward as this electron was moving. This made scientists to conclude that the cathode rays, they possess kinetic energy, and is that they exert mechanical force or momentum. So that's one of the property. Apart from that, when these were tried to be stopped by the surface of the metal, they noticed that they were able to produce cathode rays. They were able to produce X-rays. So when stream of electrons are blocked by a metal surface, they produced X-rays. So cathode rays produce X-rays when they are stopped by the surface of a metal. Apart from that, when they decided to change the types of gas inside, they noticed that the gases were glowing in different colors according to the gas. So this suggests that when cathode rays are stopped by a matter, they glow. So cathode rays, they fluorescent or glow, or they become light, or energy is turned into light. I want you to look close at our discharge tube. If you see, if you've noticed, you'll see that we have a complete circuit here. We have the positive terminal and the negative terminal connected, where negative connected to the cathode and positive connected to the anode. So this means that the current is flowing in this direction. It is going in this direction. Okay, going in this direction until it returns to what? Until it returns to the negative terminal. Now, when these electrons, these cathode rays are being produced, then they are moving on the opposite direction. They are going on the opposite direction as the current. What's the point? Another property of cathode rays is that they move in the opposite direction of the current. This is called convection current. Conventional current. So this flow, where this ability of electron produced, they are going on the opposite direction as the current flowing, it is called conventional current. So these are some of the properties of what? Of cathode rays. So now, in summary, let me bring back what are the properties of this so that we try to appreciate what we've learned. So how can we sum up our lessons? So the first thing we can say under production of cathode rays is that cathode rays are produced at a lower pressure and at a higher voltage. Okay, and we said that cathode rays are produced from the cathode and they are attracted to the anode because of the potential difference between the two electrodes. So that's a convention. Then what are the properties of this? We've learned that they travel in the straight line and they carry in the negative charge. They carry the negative charge because they are able to be attracted to the positive plate in the electric field. They are also diffracted in the magnetic field on the north pole of a magnet. We've also learned that the ionized air and gas molecules that they pass through. They also glow when they strike some matter such as zinc sulfide. We also learned that when the pressure was continually reduced between the two electrodes, it turned darker, which they call Faraday's space. So they darkened the photographic film. We learned that when the wheel was placed inside the stream, it was pushed forward, suggesting that they possess some kinetic energy and at the same time they have the momentum. We also discussed that these electrons they move in the opposite to the direction of the current in the circuit, and this is called conversion current. So those are some of the properties of this. So in the exam, when you are asked, please, you can pause the video and copy these properties. So we want now to practice what we've learned. How can we give this knowledge in the exam when we are asked? So I've extracted one of the questions that came in 2020.